So welcome to this presentation of the EPFL forecasting contest results. We were asked to forecast the hourly consumption of EPFL, and we chose 3 days. June 1st, that was a Monday. June 13th, that was a Saturday. That's the green values here. And we asked you to give a prediction interval. So here we have the different groups who provided results. 1, 2, 3, 4, 5, 6, 7, 8 groups provided results. Here I'm plotting the prediction intervals. And we computed a score that reflects both the width of the prediction interval and where the true value is with respect to this prediction interval. So we see, for example, that for the first result here, group number 1 has a good prediction, group number 10 as well, group 13 as well. Group 15 also falls in the prediction interval, but the prediction interval is very large, so probably its score is less good for this. But for the other days, the results are very different. So we see, for example, that group 14 has probably the best score for this day here. And here, for the third day, it is group 1 that has the best score. So the first take-home message is, well, for every day, there would be a different winner here. But we said we take the 3 scores and we take the median of the 2, which is a bit nasty because that means it's your second scores that matters. Here are the results. Here are the different scores for the different groups. Over taking the median of the 3 results, and the number 3 is Paul Roland, who scored number 3. So that's group number 1, whom we saw had a very good result for the first day. Number 2 is Ivan Topčić and Stefan Rotaris, and very close is Yannick Amaro, who is therefore the winner, and who will therefore receive a small present from my lab. We can use it's a dinner for 2 when restaurants are open, or the monetary value can be used for something else. So this is the diploma that will be given to Yannick Amaro. Some words about the methods that were used. It was very interesting to see that many of you used different methods. I think the whole spectrum of methods that we saw in class were used. The winner here happens to be the linear regression, but with a different linear regression model for weekday and weekend here. So whether linear regression in general is the best is not clear. And this is certain, as we saw, it's not true for all days, but overall, given the scoring method, that gave the best today. But that certainly puts the point on an important thing, that it was important here to figure out the difference between weekday and weekend, because 2 days were Saturdays and 1 was not a Saturday. So that made a big difference. The other 2 were very good, so number 2, that was quasi at the same performance, but used a very different method, used differencing at lags 1 week and 1 hour, which sort of makes sense, is the natural thing to do because of the strong periodicity of the system. So by differencing at lag 1 hour and 1 week, you automatically take care of the weekly pattern, so you don't need to model the fact that there are weekends and not weekends. And also you take care of the day and night pattern, so that's a very robust method. Here the method was done assuming IID residuals, so not trying to model the residuals more, and that in that case worked well. With a small difference, there was the same method, but modeling the residuals more sophisticated by trying to remove the residual autocorrelation of the residuals. And it turns out here that it's not the best one, at least overall, but it was the best for some of the cases here. So congratulations to all of you. I mean, all of your forecasts were very good. Of course, there are limitations in what we did, and in particular, some of the limitations is we ignored all exogenous factors. So if you are serious about forecasting energy, like people who do forecast energy are, you of course need to incorporate external information. For example, is this day a holiday? And also, because in this case, something that was used some other years, but not this year by you, is the fact that the weather also plays a role. When the weather is bad, we use more energy for two reasons. First, we put more light and heating. And second, the solar panels are not producing. So the solar panels that are on the roofs of EPFL are producing energy that is discounted from the consumption, and that also plays a role. So another way to improve the forecast would be to take data from the weather, and of course, depending on and doing a correlation analysis between the weather and the data. But this is more machine learning methods that we didn't see in class, and that, of course, can give us more mileage. Again, congratulations to the winner. Congratulations to all, and thank you very much for your work. It was very rejoicing to see all your results. Bye-bye now.